Hey everyone, I'm going to teach you Learning Target 3 from Unit 8 Sequences and Series. Today's April 20th, 2020, or whatever day you're watching this video. Learning Target 3. I can write, that's part 1, and use, that's part 2, equations of geometric sequences. So part 1, we're going to write geometric explicit equation for the sequence 2, 6, 18, 54. The reason we use equations for geometric sequences is so that we can model the sequence, and then we can use that equation to find some value high up in the sequence without multiplying over and over and over and over again by that common ratio. So let's figure out what function models a geometric sequence. Remember, an arithmetic sequence was linear, and because geometric is a different pattern, it's a different function. So right away when I'm looking at this geometric sequence, I already can figure out that the common ratio is 3 because I'm multiplying by 3 each time. I also know that the first term, a sub 1, is 2. It's written first in the sequence. So to plot this first term on a graph, I plot 1, 2. The first term is 2. The second term is 6. 2, 6. The third term is 18, so 3, 18. And the fourth term is all the way up at 54, which is off my page. Raise your hand if you can see what type of function a geometric sequence models. You got it. Exponential. Woo! So when you're thinking of geometric equations, because it follows an exponential model, we can be thinking y equals ab to the x. A was the initial value, b was the growth factor. In this case, the growth factor, what we were multiplying by each time, was 3, so that's my b value. Instead of y, we use a sub n, just like with arithmetic sequences. And then the first term was 2, and because I'm using the first term, when I write my exponent, instead of x, I'm using n. Because I'm using the first term, I have to shift to the right one. So there's my geometric explicit equation for the sequence. Let's write the formula out with no numbers in it. So it still starts with a sub n equals the first term times that growth factor, which is my common ratio. That's the base to my exponent of n minus 1. A sub 1 and r cannot be combined to become the base together to n minus 1. They're separate. R is the only number that is the base of the exponent. And this is the formula that we're going to use anytime your question asks you for the geometric explicit formula. There are other forms. A sub n equals the second term times r to the n minus 2. A sub n equals the third term times r to the n minus 3, and so on. A sub n equals a sub 57 times r to the n minus 57. But different than arithmetic explicit formulas, we can only use the first term with n minus 1 shifting to the right when it asks for a geometric explicit formula. We can use other versions to help us find information, but if they're asking for you to write the formula, you have to use that first term formula. Let's try some examples. 3 examples to write equations. Example 1, write the explicit formula given 36, 24, 16, 32 thirds, and so on. I'm going to rewrite the formula with the first term times r, that's my base, raised to the n minus 1. I have the first term, it's 36. I don't know the common ratio, but I do know that it's a fraction, less than 1, because I'm decreasing in value. So I'm going to work backwards to figure out what r is by taking 24 divided by 36. And 24 divided by 36 simplifies to 2/3. That's my r value. So my equation for the sequence is a sub n equals 36 times 2/3 to the n minus 1. Example 2. Again, write the explicit formula. Given a sub 2 equals -8, and each term is 2 times the previous term. 2 times the previous term just means that your common ratio is 2. I just wrote it out in words. So I'm going to write again my explicit formula. A sub n equals a sub 1 times r to the n minus 1. A sub n equals, I don't know the first term yet, but I do know the common ratio is 2. And even though I don't know the first term, I can find it. So I know the second term is -8. Second term is -8, and my common ratio is 2. I can just multiply by 2 to get all the following terms. But this is the second term, so I have to go backwards to find the first term, which means I'll divide by 2. So my first term is -4. So my explicit equation for the sequence is a sub n equals -4 times 2 to the n minus 1. Example 3. What if it's not so easy to find that first term by working backwards? What if the term they give us is a sub 20 equals 8,000, and they tell us the ratio is 2? They want us to write the explicit formula. So I have a sub n equals a sub 1 times r to the n minus 1. I don't know what a sub 1 is, and I don't want to divide by 2 a bunch of times. But I do know the ratio is 2. So how do I figure out a sub 1? This is when I use one of the different versions of the formula. I'm going to use the 20th term version of the formula. So I have a sub n equals the 20th term, which is 8,000, times 2r to the n minus 20. And then to find the first term, I'll just plug in 1 for n. So the first term, a sub 1, equals 8,000 times 2 to the 1 minus 20. So that's a sub 1 equals 8,000 times 2 to the -19. That's how I found my first term. So 8,000 times 2 raised to the -19. It's a decimal. Convert it to fraction form by pressing math frac. There's my first term. A sub 1 equals 125 over 8192. So now I can finish my explicit formula. I gotta write small. 125 over 8192 times 2 to the n minus 1. Part 2. Now that we've written geometric explicit formulas, let's use the geometric explicit formula to find any term. Example 1. Find the 7th term of the sequence a sub n equals 14 times 0.5 to the n minus 1. This just means plug in 7 for n in the equation. So a sub 7 equals 14 times 0.5 to the 7 minus 1. 14 times 0.5 raised to the 7 minus 1. It's a decimal. So convert to fraction form. A sub 7 equals 7/32. It makes sense that this is a fraction because the common difference was 1/2. It was multiplying by 1/2 over and over and over again. So it makes sense we have a fraction for the 7th term. Example 2. Find the 9th term. Plug in 9 for n now. Of the sequence 300, 100, 33.5, 11, and 1/9. I have nothing to plug this n equals 9 into yet, so I have to write that equation first and then input 9 into the equation. So a sub n equals a sub 1, which is 300, times r. R is a fraction, it's going down, and I'm multiplying by 1/3 each time. So that's my r value, raised to the 9 minus 1. Just plugged in 9 for n. So I have 300 times 1/3 raised to the 9 minus 1. It's a decimal again, which makes sense because my r value is a fraction. Convert this to fraction form, and there's my answer. A sub n equals 100 over 2187. Oops, a sub 9 equals that. 9th term. Last example, determine what term number, so we don't know n yet, 524,288 is, given a sub n equals 1/2 times 4 to the n minus 1. So we're going to input this large number in for a sub n and then solve for n. So we have 524,288 equals 1/2 times 4 to the n minus 1. And I'm noticing this is an exponential equation. I'm solving for n, it's in the exponent. I'm going to have to use logs, yay, to solve for n. So here's how we do it. First, divide by 1/2 on both sides. So we have 524,288 divided by 1/2. 104,856 equals 4 to the n minus 1. And then to undo this base of 4, I'm going to take log base 4 of both sides. We have n minus 1 equals, remember log base 4 is under math, scroll down to log base 4 of, I'm going to go grab that number, and we get 10. 10 equals n minus 1, add 1 on both sides, 11 equals n. If you have any questions or comments or anything, let me know. I miss you guys so much. I care about you all. I hope you're all well and happy. I hope to see you soon. Bye.